Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, I know that all of you are eagerly awaiting to learn the further concepts in the chapter real numbers. Is it not? Then let us not waste our time. Let's go for continuing the chapter real numbers. Then what you are thinking? Just boost your mind by recalling yesterday's concepts, particularly on the applications of fundamental theorem of arithmetic. What is that first application? It was all about prime factorization. Then what it is? It is the method of expressing the given number as the product of the prime factors. And second one is the uniqueness of fundamental theorem of arithmetic. It has two cases. The very first case is a raised to the power n ends with 0 if and only if the prime factorization of a contains both 2 and 5. Second case, a raised to the power n does not end with 0 if and only if the prime factorization of a does not contain either 2 or 5 or both 2 and 5. Right? And the third important application is finding HCF and LCM of given two positive integers. Then what is HCF? That is highest common factor. It is the product of the smallest power of each common prime factors involved in the numbers. Then what is LCM? That is lowest common multiple. It is the product of greatest power of each prime factors involved in the numbers. Is it not? And even we have learned the fourth point, that is the relationship between the given two positive integers a and b and their HCF and LCM. What it is? Let me go for writing. Just recall it. It is HCF into LCM is equal to A into B. So this is an important relationship, must be remembered. So many problems will be asked in the examination. Next, another important point is, then when you find out the HCF and LCM of the given two positive integers, is there any relationship between HCF and LCM? Yes, there is. Then what it is? The first point is, we know that HCF is always a factor of LCM. Then what about LCM? LCM is the multiple of HCF. Right? So, and even we had solved few problems. Now let us go for continuing that. Before that, first we will focus on the exercise problems. That is exercise number 1.2. So now you have to copy exercise number 1.2, the very first question. Yes, the very first problem in the exercise 1.2. Just go through this. It is express each number as a product of its prime factors. Here the first two numbers 140 and 156 both are already solved in worked examples. Now let us go for focusing on third one. Please don't copy, observe and listen carefully. Here 3825. The number ends with 5. So from which number it can be divided? Yes, you are right. It is 5. 5 sevens are 35. 3 will remain 32. 5 6 are 30. 2 will remain 25. 5 5s are 25. Again it ends with 5. Start dividing it by 5. 5 1s are 5. 2 will remain, it becomes 26. 5 5s are 25. 1 will remain 15. 5 3s are 15. Observe this number 153. By which number it can be divided? If you know the table, 17, you can write it directly. 17 9s are 153. But we want the prime factors. Here add them. 1 plus 5 plus 3. It is 6, 6 plus 3, 9, 9 is the multiple of 3, hence it can be divided by 3. 3, 5s are 15, 3, 1s are. Again 51 is there. So 51 is the multiple of 17, 17, 3s are. 17, 3s are 51. Now the prime factorization of 3825 can be written as, observe it, 3 is repeated by 2 times, 5 is repeated by 2 times and 17 is repeated by 1 time. So this is the prime factorization of 3825. There are. Now observe second one. Sorry, fourth one. It is 5005 And again, this number ends with 5. Start dividing it by 5. 5 ones are, zeros are, zeros are, then 5 ones are. Then 1001 is there. From which number it can be divided? Yeah. So it is better to recall divisibility rule what we have learnt in 6th standard. Here from 1 it is divisible by 1, but we don't want. It cannot be divisible by any even numbers. Obviously we can go for odd numbers. 3 it's not possible. 5 not possible. 7 even 9. Then what about 11? Let us check it out. See that here 1 plus 0. What is 1 plus 0? 1. Here this 0 plus 1. Again 1. What is 1 minus 1? 0. Hence it can be divided by 11. 11. 9s are 99. 1 will remain. It becomes 11. 11 1s are. Now 91 is there. So 91 it is the multiple of 13. What is that? 13. 13 7s are, it is 91. Is it not? So now we can write the prime factorization of 5005 as it is 5 into 7 into 11 into 13. Okay. Now observe fifth one. It is 7429. Let me write this as it is 7429. Let us go for dividing this by which prime number? So as the number ends with the odd digit, obviously it is divisible by odd number only. We have the options 1, 3, 5, 7 like that. So 1 not a prime number, no need to take. 3 cannot be taken. Why? 7 plus 4, 11, 11 plus 2, 13, 13 plus 9, 22. 22 is not divisible by 3. 5 cannot be taken because it does not end with, end with 5 or 0. Then 7 cannot be taken because it is not a multiple. 9, 11, 7 plus 2, 9, then 9 plus 4, 13. 13 minus 11, 2. It is not divisible by 11. Will not come. 30 won't come. 15 won't come. Then we have other possibility. 17. Now shall we go for 17? 17, how much are? We can go for taking 17. 4s are. It is 68. How much will remain? 6 will remain. It is 62. Now 17. How much are? It is 3s are 51. How much will remain? 11. Now take 9. It will be 119. 17. How much are? 119. 17. 7s are. Right? Next, this number 437. Again, by which number? Just by observation only, you can come to know that these numbers. This number is not divisible by the odd numbers up to 15. Even 17 will also not come. Then other option is 19. You can just go for by trial and error method. 19. 19. How much are? 19. 2s are 38. How much will remain? 5. It becomes 57. 19. How much of 57? It is 3s are. Is it not? Now the prime factorization of 7429 can be written as it is 17 into 19 into 23. Got it? So these are the prime factorization with respect to these problems in the first one. So now please pause the video and go for copying this. Yes. Now I have taken the second problem from your NCERT text. Go through this. Find the LCM and HCF of the following pairs of integers and verify that LCM into HCF is equal to product of the two numbers. Here there are two sub questions, right? The first one is you are going to find out the HCF and LCM, and second one is you are going to verify the relationship between the given numbers with their HCF and LCM. Now let us go for finding how this is. It is also very important type of problem, and even it was given in the previous year, that is particularly 17 and 18, 2017 and 18. So please do concentrate more on this. Here first we are going to find out HCF and LCM. So I am writing solution. Now 26. We have already learned how to find out them by prime factorization. here I'll write 26. Go. It is even number divisible by 2. 2 ones are 2 3s are, right? 13 is a prime. You can just stop there itself. Next, 91 is there. 91. It is. You can go for taking 13. 13 sevens are 91. Is it not? Because it is the multiple of 13. Now we can write the prime factorization of 26 as 2 into 13 and the prime factorization of 91 as 7 into 13. Next, let us find out HCF. Then what is HCF? You are going to take the common factor. What are? The common factor is 30. And least power of this common factor, just 1 only. Then 13 raised to the power 1 is 30. Right? This is HCF. Next, let us go for finding LCM. LCM is equal to, you are going to take all the prime factors involved in the number. That is 2 is there, then 7 is there and 13. Next, you can go for taking 2 as it is. 13 sevens are 91. Now 91 twos are, it is 182 or 2 ones are 2, then 2 nines are 18. 182. Now let me write conclusion for first sub question. It is, therefore the HCF is 13 and LCM is 182. Okay. Next, focus on the second sub question. You are going to verify this relation. Hence, I'll write. Shall I write solution? No. Then what should be written? We have to write verification. Here I am writing verification. What we have to verify? Whether this part, LHS part, HCF into LCM is equal to the RHS part, product of the two numbers. Please do remember, don't take both of them together, because you are going to show that whether this part is equal to this part. Hence, take them separately, at last compare. I go for taking first LHS part, it is HCF into LCM. Then what is HCF? Just we have come to know, it is 13. And into LCM is, just we have come to know, 182. Next, multiply these two. What is? 13 twos are 26. 2. Then 13 eights are, it is 104. 104 plus 2, 106. It is 10 will remain. 13 ones are 13. 13 plus 10, 23. So 2366. It is LHS part. Now I go for taking RHS part, that is, what is? Product of the two numbers. Product of two numbers. Then what are those? It is, the numbers are 26 and 91. Let us multiply them. You can go for taking the table 91. 91 6 are 9 6 are 54. 540 plus 6, 546. So 54. 91 twos are, it is 182. This is 6. 13 carry 1 2. So 2366. The table, as it is 2-digit number, you find it very easy to multiply. You can go for this method, or else you can go for the lower class method, that is 91 into 26. Then you will multiply 6 ones are, then 6 nines are, then 2. Better to practice like this. Now observe LHS. LHS is 2366 and RHS is 2366. Both LHS is equal to RHS. Hence, we can say that HCF into LCM is equal to the product of two numbers. Hence, the given statement is verified here. Hence, the given statement is verified. I hope that you all have understood this. So please pause the video and copy from there to here quickly. Now we will move on to the second problem. It is 510 and 92. Again here you are going to find out the HCF and LCM, and also you are going to verify the relationship HCF into LCM is equal to the product of two numbers. And this is very important, and it was also given in the examination. You can just put star mark. Now please don't go for copying. Observe the board and listen my words without fail. Now 510. Let us find out its prime factorization. Dear students, repeatedly I have been reminding you, please use scale and pencil to draw the lines. Here 510 is there. The number ends with 0. So it is divisible by either 5 or 2. Then I go for taking 5. See that 5 ones are, then zeros are. 5 tens are 50. 1 will remain, it is 10. 5 twos are. 1 or 2 is there, it is even. Then it can be divided by 2. 2 5s are, then this is 1s are. Then 51 is there, it is 17 3s are. Okay. Next 92. Here 92, it is even number, it can be divided by 2. 2 4s are 8, 1 will remain, it becomes 12. 2 6 are 12. Then 46, again it is even, 2 2s are 3s are. So 23 is prime, you can just keep that as it is. Now let us write the prime factorization of both. 510, it is 2 into 3 into 5 into 17. Then 92, it's equal to 2 square into 23. Then let us find out HCF. In case of HCF, here the common factor is 2, least power is 1, hence HCF is 2. LCM, it is, let us go for writing all the factors, taking all the factors. 2 is there, 3 is there, then 5 is there, 17 and 23. Now highest power of each prime factor, highest power of 2, it is 2. 3, 1, 5, 1, 17, 1 and 23, 1 also. It's equal. Now let us go for multiplying. Follow this method. It's very simple. What is 2 square? It is 4. 4 5s are 20. 23s are 60. Then you go for multiplying these two. 17 3s are 51. 5. 17 2s are 34. 34 plus 5. It is 39. Now this is equal to, write 0 as it is, multiply 391 by 6. 6 1s are 6. 6 9s are 54. 5. So 6 3s are 18. 18 plus 5, 23. Got it? So HCF is 2, LCM is 23,460. I go for writing the conclusion here. Conclusion for first sub question. Therefore, the HCF is 2 and LCM is, it is 23,460. After this, what is the second sub question? Yes, you are going to verify the relationship. Alright, verification. In verification, first you have to find out the product of HCF and LCM. So that is the LHS part. LHS equal to HCF into LCM. What is HCF? HCF is 2. What about the LCM? LCM is 23,460. Go for multiplying these two. So keep that 0 as it is. 2 6 are 12, carry 1. 2 4s are 8, 8 plus 1 9. 2 3s are 6, 2 2s are 4. 46,920. Then I go for taking RHS. RHS is what? It is product of two numbers. What are those numbers? The numbers are 510 and 92. This is also very simple. 0 is there. Write 0 as it is. 92 ones are 92. 9 is the carry. 92 5s are 92 10s are. It is 920. 5s are. It is 460. 460 plus 9. 469. Got it? It is such a simple multiplication. Or else, again, as I said, the lower class method can be followed in the working column. Actually, not necessary to solve such simple problems. Anyway, observe LHS and RHS values. 46,920 in case of RHS, 46,920. We can write LHS equal to RHS. Then conclusion for second sub-question. Hence, the given statement. You can also write that statement. Hence, the statement that is HCF into LCM is equal to product of two numbers is verified. Clear? I hope that you all have understood. This is very important one. I have put double star mark. Please do practice the problems like this. Now again, you should pause the video and please copy from there to here. Now let's move on to the third sub question. Some of the things I have kept ready. Now observe 336 and 54 is there. Now let me go for finding the prime factorization of both the numbers. First 336, it is even number. Start dividing it by 2. 2 ones are 2. 1 will remain, it is 30. 2 6 are 12. 1 will remain 16. 2 8s are. Next, again it is divisible by 2. 2 8s are 16. 2 4s are. Then even number, start dividing it by 2. 2 4s are. Then 2 2s are. Next, 2 2s are 1s are. 21. It is 3 7s are. Next 54 is there. Let us write here. It is even number. Start dividing it by 2. 2 2s are 4. 1 will remain 14. It is 2 7s are. Then 27. It is 3 9s are. 27. 3 9 is there. 3 3s are. Now I can write the prime factorization of 336. It is 2. How many times? 4 times. Into next 3 into 7. Another one 54. 54 is equal to 3. How many times? 3 times and into 2. Now observe. Let us go for finding first HCF. What is the common factor? Common factor is 2 and even 3. There are two common factors. What is the least power of 2? Here is 4, here is 1. Least power is 1. And another common factor 3. What is its least power? Here is 3, here is 1. Least power is 1. It is equal to 2 raised to the power 1 is 2, 3 raised to the power 1 is 3. 2 3s are. It is 6. Now let us go for finding LCM. LCM is equal to, let us write all the prime factors. The prime factors are 2, 3 and one more 7. Then here we will go for taking their highest power. What is the highest power of 2? It is 4. Highest power of 3? It is 3. Highest power of 7? We can keep that as it is. It is equal to, what is 2 raised to the power 4? 2 raised to the power 4 means 2 into 2 into 2 into 2. How many? How much it is? 2 2s are 4, 4 2s are 8, 8 2s are 16. So 16 into 3 cube. 3 into 3 into 3. 3 3s are 9, 9 3s are 27 into 7. Now I'll go for finding the product here. It is equal to, now first you go for multiplying 60 and 27. So 16 sevens are. How much it is? It is 112. 11. 16 twos are. It is 32. 32 plus 11. 32 plus 11 is 43 into 7. Next, multiply by 7. 7 twos are 14. Carry 1. 7 threes are 21. 21 plus 2, 22. 2. 7 fours are 28. 28 plus 2, 30. 3024. Here. Now, here I write the conclusion. Therefore, HCF is 6 and LCM is 3024. Now, let us go for verify the statement. That is whether HCF and LCM, HCF into LCM is equal to product of two numbers. It's not final conclusion. Now, we are going to verify this. So, HCF is 6 and LCM is 3024. Multiply them. 6 fours are 24, 2, 6 twos are 12, 12 plus 2, 14, carry 1, 6 zeros are 0 plus 1, 1, 6 threes are 18. So, 18,144. Next, product of two numbers. The numbers are 336 into 54. Here, the number 54 is there. It is also simple. See that 56 are how much? 300. 4 6 are 24. 300 plus 24, 324. 32 is the carry. Then 54 3s are 53s are 150. 4 3s are 12. 162. It is 491. So 4 19 is the carry. Again 54 3s are 162. Then 19. It is 1 carry 181. So it is 181. Got it? See that? LHS and RHS both are same. Repeat it. I have been telling, if the two digit numbers are there, you find it easier to multiply them. Then if you do not know, then again I am reminding you, please you can use the lower class method, that is 336 into 54, then multiply first from 4, then right here, then next from 5 and right here, then finally you can write that product. So anyhow, LHS is 18,144, RHS 18,144. LHS equal to RHS, hence the given statement. What is that statement? HCF into LCM is equal to product of two numbers is verified. Got it? Again and again I have been repeating that this type problem is very important in the examination point of view. Please do practice as many times as possible till you be perfect regarding this type problem. Okay. Now you have to pause the video and copy from here to here. Yes. Yes. In that exercise, it is third question. That is exercise number 1.2. The third question is like this. Here they are given three numbers. Here also you are going to find out HCF and LCM by prime factorization method. Here it is. Prime factorization. Now let us go for learning this. Already I have given you the examples, the worked examples. Now let's move on to these textbook problems. First one, 12, 15 and 22. 12. What is the prime factorization? You can directly it can be written, or else you can go for this method. 12 is there, even number, 2 6 are then 2 3 are. 15 is there, divide 15 by 5, 5 3 are 15. Then 21 is there, you can write 7 3 are. Now let me go for writing their prime factorization. 12 can be written as 2 square into 3. 15 can be written as 3 into 5. And 21 can be written as 3 into 7. Got it? Now let us find out HCF. HCF means, first you have to take the common factors. What are the common factors? Here 3, 3, 3. This is the only common factor present. So we can write you have to take the number or the prime number which is common in all these prime factorization. So 3 is there. Hence we can write HCF is 3. LCM. Now we have to write all the factors. What are the factors? 3 is there, 2 is there, 5 as well as 7. Now then go for taking the highest power of each prime factor. 3, highest power is 1, 2, highest power is 2, and 5, 1, 7, 1. Now see that. What is 2 square? 4. It is no rule that you have to start multiplying from here only. You just go for easy method where such possibilities are there. See that? I tell you in a simple way. What is 2 square? 4. 4 5s are 20. 23 is a 60. 6 7s are 42. So 67s are 420. Clear? This is such a simple. Therefore, HCF is 3 and LCM is 420. I hope that you all have understood. And in case of verification, here actually they have not asked, and you should not think that the product of these three numbers is equal to the product of HCF and LCM. There is a separate relationship for that. I give you that information at the end of this chapter. Clear? Okay. Next, let us move on to second one. 17, 23 and 29. Observe. Just by observing these three numbers, you can come to know. Could you tell what type of numbers are these? Do you say that just odd numbers? No. Apart from that, they are all prime numbers because they have only two factors, 1 and the number itself. Now, here we can write 17, 23 and 29 are prime factors or prime numbers. And we all know that the HCF of prime numbers, it is 1. So, here I'll write, we know that HCF of primes, nothing but prime numbers, is 1. Therefore, then could you tell what is the HCF of these numbers? Yes, you are right. HCF of 17, 23 and 29 is 1. This is such a simple one. Now, let's move on to third one. Here the numbers are 8, 9 and 25. Here I go for actual method. 8, then 2 4s are 2 2s are. Next 9, it is 3 3s are. Next 25, it is 5 5s are. Now we can write 8 as 2 cube, then 9 as 3 square and 5 as 25 as 5 square. Here I'll write first HCF. What do you say? You can say that there is no common factor only. If there is no common factor, it is understood. 1 will be there because here 8 can be written as 8 into 1 and even 2 4s are, then 2 2s are, 2 1s are, into 1 into 1 into 1. The common factor will be 1 only. Then why we did not consider when I was writing here? Because they had asked it should be found out by prime factorization. So here there are no common factors. Therefore, HCF is 1. Here I write there are no common factors. If I write only this much, it will not be suitable. Why? Because there is common factor 1. So you can write there are no common factors except 1. Therefore, HCF is 1. What about their LCM? LCM, obviously we have to take all these. That is 2 cube, 3 square into 5 square. Now what is 2 cube? It is 8. 3 square, 9. 5 square, 25. Then how to multiply? Here also simple method. 25 is there. 25 8s are 25 4s are 100. 25 8s are 200. 200 9s are 200 9s are 2 9s are 18. So it is 1800. Clear up? Therefore, you can write the conclusion as HCF is 1 and LCM is 1800. So in the third problem, 3 sub problems are there. We have solved all the 3. Please pause the video and then go for writing from there to here. Quick. Yes. Now let's move on to fourth one. Observe. It's very nice. Given that HCF of 306 and 657 is 9. If it is so, then you have to find out the LCM. Dear students, in yesterday's class only I told you, we have a relationship, we have a statement which gives the relationship between A and B and their HCF and LCM. That is, HCF into LCM equal to product of two numbers. And even I had told you that when 3 terms are known in that, you can find out the fourth term easily. Here also we are going to follow the same. We know the numbers and HCF. You are going to find out LCM. That is, can we write LCM as it is A into B by HCF? Yes. Okay. Now, to solve this, I go for using the statement. We know that HCF into LCM is equal to product of two numbers. Right? Okay. Next. We want LCM. So I write LCM of the given numbers. The given numbers are 306 and 657 is equal to product of two numbers. The product of two numbers 306 into 657 divided by HCF. What is the HCF? They were given. It is 9. It is equal to, now it should be cancelled by 3 because both are multiples of 3. 3. It is 3 3s are. Then this is 3 1s are, 0s are, 2s are. Into 657. Then can we go for cancelling this one? See that 6, 7 plus 5, 12, 12 plus 6, 18. Multiple of 3. 3 1s are 3. Here 102 into 3 2s are 6. 3 1s are 3. 2 will remain 27. 9s are. Next, it is 102 into 219. Let us go for multiplying this. See that 102 is there. Very simple number. 102. Now, first 100 9s are 900. Then 2 9s are 18. So 918. 8 is the carry. 91 is the 91 will remain. Then 102 1s are 102. 102 plus 91. 391, 193, 3, then 19 will remain. Next, 102 2s are 204. Then 9 plus 4, 13, carry 1, 2, 2. It is 223. So 22,338. That is LCM. Clear now? Okay, now you just observe fifth one. Check whether 6 raised to the power n can end with 0. End with the digit 0 for any natural number n. Already it has been verified in the worked example. If a number satisfies uniqueness, then we can say that a uniqueness of FTA, then we can say that whether it ends with 0. So I'll write verify. Now, please pause the video and copy from here to here. Yes, go. Look here. Here we have sixth problem. and before that we have solved fourth and fifth. Fourth problem, usually it will be asked in the examination for 1 mark. Just I had forgotten to tell you that, now I am reminding you. Now this is sixth one, go through this. Explain why 7 into 11 into 13 plus 13 and another number 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. They are only telling that, no doubt, these two numbers are composite. But why these two numbers are composite? So now we are going to give a reason for this. We are going to give justification for this. That is, why these numbers are composite numbers. Just to recall the definition of composite number. A number that has more than 2 factors is called a composite number. Then here you may say that many factors, right? No, there are just 2 terms only. They are which are separated by plus sign here and here. Now we have to show that this number has more than 2 factors. I will go for giving justification or reason. Justification. It is, let us take the first number. Why this is composite? So 7 into 11 into 13 plus 13. Here could you tell how many numbers are there? There are 2 numbers which are separated by plus sign. This is one number and this is another number. And when you observe, you can come to know in these 2 numbers what is common? 13 is common. Hence I will go for taking 13 as common factor. Remaining, in first number what will remain? 7 into 11 plus as it is. Here what will remain? 13 is already taken out. 13 1s are 30. Clear? It is equal to 30 into, see that 7 11s are 11 7s are 77. 77 plus 1, 78. Clear? Now, how many factors are there? Do you say that 2 factors? No, more than. See, 78 is even. It can 78 can be split up as 2 into 39, like that. So, or else 13 into 78 into 1. Can we write so? Because 1 is a factor of all numbers. How many factors are there now? More than 2 factors. Therefore, this number is composite. Here I will write, it has, that is the given number, has more than 2 factors. Therefore, the given number is a composite. And you can go for giving justification in another way as multiplying this plus, that is adding this number. You will get the whole number and you will go for finding the factorization. In that factorization you can come to know more than 2 factors. But you find it, this method is easiest one. I will go for taking the second number. Second number is, it is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. It is equal to, here how many terms are there which are separated by plus sign? There are 2 such terms or numbers are there separated by plus sign. Then what is the common factor here? Yes, you are right, 5. Then can we take 5 as common factor? Yes, 5 into what will remain? 7 into 6 into 4 into 3 into 2 into 1 plus 5 has been taken as common factor, it is 1. It is equal to 5 into, now see that, go for multiplying this. Here 4 3s are 12, 12 2s are 24. Now 7 6 are 42. you just go for grouping and multiply. It will be easier. 7 6 are 42 into 4 3 are 12, 12 2 are 24 plus 1. It is equal to 5 into, you are very familiar with the table, 24. 24 2s are 48, 4 will remain. Then 24 4s are 96, 96 plus 4, 100. It is 1008 plus 1. It is equal to 5 into, what is 1008 plus 1? It is 1009. We know that 1 is a factor of all numbers, hence I can write into 1. How many factors are there? Here, more than 2 factors. Total there are 3 factors here. It is more than 2 factors, therefore the given number is composite. Here I will write, it has more than 2 factors. Therefore, the given number is a composite number. Or just you can write composite. I hope that you have understood. Please do follow this method. You find it definitely easier to answer for this. And this is also very important problem in the examination point of view. You can put double star mark. Now, please pause the video and go for copy from there to here. Copy. Yes. Here, just observe 7th problem. It is the last problem in this exercise. Statement problem has been given. Just go through this and understand when I am reading only. Let us go through this one. There is a circular path around the sports field, right? Then Rohit takes 18 minutes to drive 1 round of the field. While the Harshit takes 12 minutes for the same, that is for 1 round. Suppose they both start at the same point and at the same time and go in the same direction. Got it? If this information is there, then we are going to find out after how many minutes will they meet again at the starting point. I hope you all have understood this. Once I go for telling the meaning, just I had read, now I am going to tell the meaning of this whole statement. There is a circular path around a sports field. See that this is the sports field, and there is a circular path around it. This is the circular path. Next, Rohit takes 18 minutes to drive 1 round of the field. From which point? Assume that this is the point from which the Rohit will start moving, driving, and it takes 18 minutes to complete 1 round. Similarly, why? Harshit takes 12 minutes for the same. Harshit here also, his position is also same, from the same point. He will also start moving and he completes 1 round in 12 minutes. Then, suppose both start at the same point, this is the point, and at the same time and go in the same direction. Assume that both will start moving in the same direction, that is in clockwise direction. Now, if it is so, we have to find out after how many minutes will they meet again. See that here, who is taking more time to complete 1 round? Rohit. So, by the time Rohit completes 1 round, Harshit, he will take just 12 minutes to complete and he moves ahead. Is it done? Now, after how many minutes? See, after how many minutes both will go for meeting again at this point? Now you tell whether it belongs to HCF or LCM. If they want to meet again at the same point, means they should keep moving 1 round, 2 round, 3 rounds, 4 rounds, like that. Every time that time is being multiplied. See, Rohit in first round he takes 18 minutes, and next after second round it will be 36 minutes. After third round it will be 54 minutes, like this. What about Harshit? He takes 12 minutes to complete one round, and he takes 24 minutes to complete two rounds, and he takes 36 minutes to complete three rounds. Now see that. Now by the time Rohit completes two rounds, and at the same time Harshit will complete three rounds. Clear? Now after how many minutes? After 36 minutes, both will meet again at the same point. As it is being multiplied, it belongs to LCM. We will go for finding LCM. Now let me write data. First one is time taken by Rohit to complete one round. Time taken by Rohit to complete one round. How much? It is 18 minutes. 18 minutes. Next, time taken by Harshit to complete one round. It is how much? It is just 12 minutes. 12 minutes. The time after which both will meet again. Here I'll write time after which both meet again at the same point. It is going to be found out. Then calculation. As we know that here you are going to find out the LCM. I'll write just time to be found out, after which both will meet again. It is LCM of both the numbers. One is 18 and another one is 12. Let us go for finding the LCM. It is 18 by prime factorization method. 2 9s are 3 3s are. Next 12. 2 6 are 2 3s are. Now 18 can be written as 2 into 3. How many times? 2 times. Then 12 equal to 2 square, because 2 is repeated by 2 times. It is 3. Now LCM equal to, it is all factors 2 and 3. All factors. The highest power of 2 is 2. 3 is 2. It is equal to, what is 2 square? 4. And 3 square? 9. So 9 4s are 36. See that? 36. Therefore, we can say that both Rohit and Harshit will meet again at the same point after 36 minutes. Here I will write the conclusion. Therefore, the time after which Rohit and Harshit meet at the same point. Same point is how much? 36 minutes. I hope that you all have understood this, and you have to practice this one. Based on that, some other types of problems are there. We will solve that in the next class. Now you have to pause the video and copy this question and solution complete. Copy that. Yes, I hope that you all have copied this. Now with this, the exercise 1.2 has been completed. And before concluding the class, just I'll give you one information. In these 6 days in mathematics, we have solved many problems, and some problems are very important in the examination point of view, which you must practice. Just I have listed them. Let me show you with the chart. Observe this. Look here. Here from real numbers, the very first one we learned properties of positive integers. In that there are two properties, one is EDA and second one is FTA. You must learn the statements of these two. Next, second one, we found out the HCF of positive integers by Euclid's division algorithm. Here two such problems are there. Please do practice. Third type is show that any positive integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5, where q is some integer. This type is also very important in the examination point of view. Fourth one is, in the first exercise only, one problem is there. Square of any positive integer is of the form 3m or 3m plus 1 or for 3m plus 1 for some integer m. Likewise, even cube of any positive integer is also there. Practice it. And fifth one is, just today only we have learned that check whether 6 raised to the power n can end with the digit 0. It is based on uniqueness of FTA. And one more, that is finding the HCF and LCM of the three positive integers using prime factorization. Next, this is very important problem in the examination point of view. Find the HCF and LCM of the given numbers and verify the statement. This is HCF into LCM is equal to product of the two numbers. And one more, and when three numbers, that is two numbers with their HCF or LCM are known, you can find out another term by using this statement. One such problem is there and that has already been solved today. Very important one. This is just we had come to know how to say the given numbers are composite or not. It should be practiced. And one more, I think in yesterday's class only we had done this one. If HCF of 117 and 65 is expressible in the form 117m plus 65n, find the value of 5 into mn. So these are the most important problems which you must practice without fail. Okay. And one more information, dear students, you all know that tomorrow the whole world is going to celebrate the International Yoga Day, and we must feel very proud because the yoga has been originated from our country and it is very good for our physical health, mental health and spiritual practice. So please do practice yoga every day just for 5 to 10 minutes with the guidance of your yoga teacher. Okay, once again, happy Yoga Day, International Yoga Day. Thank you.